afraid to ask those questions. You need to ask the questions. So the average rate of change is just the slope between 2 points, algebra 1 material. The slope of the tangent line is the instantaneous rate of change. That's the calculus, taking the limit of what you did over here. That's all. Because this is actually the slope of this line. That's your average. Where the red one is at this instant. Okay, so let's talk about something you have more familiarity with. Let's talk about your speed or velocity. I want to talk about velocity because that's where I messed up. So your average velocity, now, if I go to Chicago and it's 400 miles and I travel for 8 hours, my average velocity is 50 miles per hour. It's all the velocities over that interval. It's my average. So how do you find it? You find your position, that's position. And some people don't like the fact that I use an S, but that has been accepted in the math community. So we're stuck with it. Yeah, well, you'll get used to it. Of T1 minus the position at T2, it's just the slope, divided by T1 minus T2. So if I use my Chicago example, you go 400 miles in 8 hours, because you're probably going to stop along the way. You're going to average 50 miles per hour. That's the slope of the secant. Yes, let's write that. This is yesterday's pushed together, looking at big ideas only. Yes. Okay, that's your average velocity. What's your instantaneous velocity? You know what it is. You all drive cars, right? That's what's on your speedometer. So V instantaneous is the derivative. Okay, so if S is position, how do you find the velocity? It's the derivative of S of t, dSdt. Okay, guys, that's always the back row. No, no, no. Here's the deal. It distracts me, it distracts others. And when I get distracted, then I don't do a smooth presentation. So that's the problem. So let's not. Do it later. Okay. Do you understand that this is the derivative? It's the first derivative. Is that okay? S is being like this, position. Then V is equal to ds dt. Or you could call it S prime of t. Yeah, you can do that. Okay. So let's put it in there. Yes. This is S prime of t. Yes. 1/2 at squared, yes. The physics one, yes. You'll be given something. Okay. How do you find your acceleration? What is acceleration? It's the change in your velocity over the change in time. So it's the velocity at the first time minus the velocity at the second time divided by the change in the time. This is the average. Okay? What is the instantaneous acceleration? I look at it this way. Those deltas get really small, we'll make them d's. That's just the way to do it. So the instantaneous is dv dt. What derivative is that of the position? Remember, v is ds dt, right? I'll get you the primes, too, because I didn't think about that. Now, this is not a mathematical explanation, but it helps you remember. Okay, Noah? How many d's do you see here? Well, that would be true, probably. But I mean in the top row, d times d is d squared, right? This is a notation. We've done this, but you might not remember it. How many dt's? 2. Now, that's why I said mathematically it's not right, because I should have parentheses, and we don't write it. It just means the second derivative. It means s double prime of t. That's what it means. So the acceleration is the change in the velocity with respect to time. If time changes, how does your velocity change? That's s double prime of t. That's, honestly, that's all we talked about yesterday. Was that it? Let me look at my notes. Yeah, we can do some problems. Okay, then we talked this way, the other way. Okay, and I put it in a PDF file so you can print it, and everybody should have Acrobat Reader because it's free. So that shouldn't be a problem, but you can print it here. If you print it in the library, you can get it in color. Okay, how do you find your speed? Velocity is a vector. Let's review that. Velocity is a vector. If velocity is less than 0, which way are we moving? Left or down? I care about that. If velocity is positive, then it's right or up. If the velocity equals 0, then we are stopped. We're stopped, right? That makes sense? Okay, James? Did you miss this yesterday? Okay, so that's important. It's a vector. So how do you find your speed? Casey, do you remember? Because that's where I messed up yesterday, because I took the question I answered was velocity. That's not the question that was being asked. It's the absolute value of the velocity. Now, when they ask for speed and things, it's probably going to be in the calculator part, because that's hard to do numerically. And you'll see what happens, because we're going to be given velocities. You're going to have to do position and stuff. But right now, we're not ready for it. Okay, so how do you know if a particle is speeding up or slowing down? This is really important. Everything here, if you have these notes, is exactly what you need to be looking at the few weeks before the exam, because this is a summary of everything. If it's speeding up or if it's slowing down. And you don't have to memorize it if you're willing to think a little bit. If it's speeding up, think of the guy jumping out of the helium balloon. Is he speeding up? Yes. Why? What's the acceleration? Negative. What's his velocity? Negative. So if the velocity and acceleration have the same sign, you're speeding up. That's all you have to look at. And it's all you have to say, by the way. So A and V have the same sign. They're both in the same direction. So I'll write it both ways. A and V are in the same direction. Even though they're negative, it doesn't matter. Same sign. But if you, you could memorize it, or you could say, oh, I'm going to drop the pencil, or remember the guy jumping out of the plane. Whatever. Whatever works. Doesn't matter. Okay? Now, if I take my pencil and I throw this up in the air, is it going to slow down? Yeah. What's true about the velocity? It's positive, but the acceleration is negative. So when you are slowing down, A and V are opposites. A and V are opposite directions for opposite signs. Does this help, I hope? Because this says it all as succinctly as I can. Well, and it didn't hurt me. You heard it yesterday, and so today I'm coming back, and now it should be making a little more sense, which is why it helps to read the book before you come to class. I know you've never done that, but it helps. I know, because I was in a math class I found very hard, and when I read the book before I came to class, I found the teacher much more easier to understand. In fact, let me put this in my fancy stuff here. Let's use that one. Because they're going to ask you this question, but you have to read the question carefully and make sure you answer the question, because that's what I did wrong yesterday on E. I answered the wrong question. We can go back and look at that. And then one last thing would be the physics equations. So let's go ahead and put those in. Ready? It is kind of cool, but you couldn't read anything then. It's the only problem. And this is for a constant acceleration. And later on, we will start with the acceleration and get this formula. But those of you in physics, you might remember it, 1/2 at squared. Yes, we'll give it to you because not everybody's in physics. But everybody should take physics in their life so they understand how their car works. Sure. This is the math, yeah. Initial velocity, v naught, original velocity, doesn't matter. Then, what's the velocity? You can, once you know this, you can find the velocity, can't you? Because what is the velocity? It's ds dt, or if you prefer the primes, it's s prime of t. Oh, you want it kept up here? Till somebody erases it. But we're going to give it to you anyway. Okay. And, oops, what is the derivative of this? What happens to the 2 and the 1/2? They go, right? So the derivative of this, a is a constant, so it's a times t. What's the derivative of the initial velocity times the time? Why is this that? Because it's 1/2 a times the derivative of t squared, which is 2t. Because that's the formula. I didn't say where the formula comes from. I will later on this year. This is s. What's the velocity? It's the derivative. Okay, what's the derivative of v naught t? V naught. What's the derivative of your initial height? Because this is just a number. What's the derivative of 3t? It's just 3, right? You look at the variables here and say they're variables. No, they're not. Those are numbers. S0 is a number, 100 feet above, whatever it is. I don't care what it is. So making this look prettier, v is equal to at plus the initial velocity. You can do vi or vo. It's a constant velocity. Okay? And how would you find the acceleration? It's the derivative of the velocity with respect to time, or s double prime of t. And what is the derivative of that? Yes. S. Yes, this one. There's no, oh, this is a number. What's the derivative? This is a constant. What's the derivative of a constant? It's 0. But this is a constant times time. It's like the derivative of 3t or 3x. What's the derivative of 3x? It's 3. And I know, because t is a variable, v naught is not a variable, and I'm so used to it, I easily differentiate it. Not so easy for you. So what is acceleration in this equation? It's just a. Make that seem almost seems silly to write it. Actually, it's not a constant velocity. This initial velocity is a constant, but the velocity that you have is the acceleration times the time plus the initial velocity. Yes. This is the same acceleration all the way through. It isn't. Position. Yes. Okay, we're going to do some problems. Definitely need to finish 9E and do it correctly. Okay, because 9E was not correct. Should we just attack the whole problem again real quickly? We can. You're right in there in your homework. that you need to try them, and I know that I think the assignments are long, but okay, are we ready to try some problems? Now, should we just redo 9? Wouldn't hurt. Sometimes you have to back up. So my function is this, and the first question is to graph this. But you should be able to graph that, because you know it's a what? Alexi, why do you have nothing out? You are forever immortalized on the video. Honestly, guys, you should watch the videos, I think, because some of them are pretty funny. We'll do 8 too, okay? No, I got Alexi this time.
Should do a video montage.
Twice now.
That'd be a nice project. Somebody's going to do that last year. Okay, are we ready? Okay. And the back row? Okay. You guys, you know it's a parabola. It looks like this. If you don't, I think we're in trouble. But so I'd like to find out where it intersects the x-axis. Well, where is that? Okay, you guys? 0 and 4. From higher algebra, do you remember where the vertex is?
2.
It's halfway. Okay, so we're not going to include the left part of the parabola, but there it is. That's f of t. That's A. Number 9.
We have to do this for like.
Because this is a parabola. What's y equals x squared look like? Well, it really has this. But it said I'm only going to go from 0 to 5. Okay, back row? Now, how do I find b, which is the velocity? What's the velocity, which is f prime of t? So you're going to find the derivative of that. It's what? I just can't hear you. 2t, right? 2t minus 4. That's all it is. Don't make it hard. Let's graph that one. So at negative 4, we're going to be here. It's going to look something like that. It may not intersect that the curve. I don't know. This is the velocity. F prime of t. And then what would be the next thing to find, since we're here? Acceleration, right? So what's the acceleration? It's the second derivative. Now, this is not a physics equation, although this is still a parabola. So what's the acceleration there? 2. Because it's the derivative of this function here. They gave us this. So find the velocity. You just take the derivative. Then find the acceleration. It's the derivative of it. What? These are the intercepts. Yeah. What could you do? Could you just plot points? Could you find f of 0, f of 1, f of 2, f of 3? Sure you could. I just did quick graphing because it was easy. Mm-hmm. The velocity is the derivative of this. Think of this as s of t instead. Because they called it that. Yeah. They should call it s of t. It would make more sense. What's the acceleration? This is the velocity equation. How do you find the acceleration? It's the derivative of the, yeah, you're taking derivatives of derivatives. It's the derivative of the velocity equation. Okay, ready? Let's graph this. Acceleration is 2. I don't know exactly where it is, but that's close enough. Okay, now we can answer all the questions. Okay, so A was graphing it. Oh, I'm in the wrong place. B. And they have a nice little example of it, actually on page 175, almost the identical problem. So you could test yourself on that one. Okay, we graph the position. B, find and graph the velocity function. We did that. When is the object stationary? Now, it says only when. How do you know if it's stationary? Here's the deal. When we do the exam, we got to get ready for this now. We have to show our work. And they're going to ask you to justify your answer. How do you know it's stationary? Because what's true? B equals 0. You get a point for making that statement, even if you can't solve for V equal to 0. This was an easy one, though, right? When is this stop? At T equals 2. This is still B. That's why I haven't changed it. When is it? It says when is it stopped? Sure it does. When the velocity is 0, 0 equals 2t minus 4. What value can put in there to make it true? 2. And if you look at the graph, you can see it there, which is nice about the graph. That's it. It stopped when t is equal to 2. Okay, you get 1 point for the v equals 0 and 1 point for t equals 2. We'll do a practice AP problem, I hope tomorrow. Probably tomorrow. I'll see if I can get it done. I mean, it's done. And you'd be surprised. We're only going to give you the parts you can do, and that parts you can do right now are worth 6 out of 9. If you can average 6 out of 9 on free response questions, you're going to get a 5. And when you see it, it'll be a little scary because of the wording. When you realize what's being asked, you're going to go, oh, that's not that bad. You can certainly go back and look at all the old exams. I don't have the time to do it, but they're there. Okay. It says, when is the object moving to the right? So when is it moving to the right? When, not t, but v is greater than 0. So when is that? Now you got to be careful here. Okay, Riley? Brian? When is this positive? When the velocity is positive. Now, when is the velocity positive? Starting where? 2. Do I get to include 2? No, it stopped there. Do you hear the difference? I know it's picky, but it's true. It stopped at 2, but what about at 5? It's still moving. Velocity's positive, so I get to include 5. I'm on an interval. They closed the interval for me, which was actually quite nice. Okay, when is it going to the left? When v is what? Less than 0. So when is the velocity less than 0? 0 and 2. Now, do I get to include the 0? Is the velocity negative at 0? Yes. And then, and at 2, is the velocity negative at 2, or is it 0? Okay, I don't know how picky they're going to be. I think they'd be picky about this. But there's only so much we can be picky about because we have 500,000 tests to grade. It's 8 hours a day for 8 days. But it's fun. And I learned so much. Okay. Oh, wait, because I'm talking with other people who are nerdy as me.
Have you ever had like a paper where the person just like doesn't know what they're doing at all?
No. Oh, on the exams. I thought you meant the graders. Oh, yeah. Lots of that. Okay. Determine the velocity and acceleration. So you know what I want? I want v of 1 and a of 1. Well, a of 1 is easy. What's the acceleration no matter where we are? What's a equal to? 2. Acceleration is constant. It's just a constant 2, period. What's the velocity at 1? Well, my velocity is equal to 2t minus 4. So this is going to be 2 times 1 minus 4, which is negative 2. Now, if that's the case, the velocity is negative, acceleration is positive. What's the object doing? It's slowing down. We'll look at the picture in a second because we're going to do E. That was C, and then is that all it has for C? I think so. D, determine the acceleration when the velocity is 0. Although this bothered people, I want A of 0. The acceleration is still what? 2. People say, well, they're stopped. But remember, acceleration is the change in the velocity. So the velocity is changing at when you're stopped. Yes, there is. If I drop my pen, that's negative acceleration. It's a direction. Acceleration, when you do those with the positive and negatives, is really the direction of your force. Okay, so let's look at this picture right here. And let's see what's happening. Because what I did wrong on E was I read it wrong. I thought to myself, they didn't really mean that, but yes, they did. It says, on what intervals is the speed increasing? Well, you know what I did? I said, when is the velocity increasing? That's not the same thing. The speed, that's the magnitude of the velocity. So what's happening? My velocity is negative, but is velocity increasing here? Yeah. It keeps increasing until I do what here? I stop. Well, these are negative velocities. That just means I'm going backwards or down or whatever, how you want to do it. I'm in my car. I'm going backwards. I want to go forward. What must I do? I must stop. And what's true about my speed then? Because the velocity is negative, but the acceleration is positive. I'm slowing down. I have to slow down to stop. So what I did wrong was I did velocity. The velocity is increasing on the whole thing. That's true. But the speed is not increasing here. It doesn't start increasing until we get to 2. And it goes 2 to 5. I'm going to leave that open to, I really think it should be open. I don't think that there's agreement on that. So I don't think you're going to have to worry about it. I mean, if you look in different books, different people say different things. But I'd rather be more particular. So then the next question was, so that's what I messed up. Next question was number 8. And 8 looks really terrible, but it isn't that bad. So are we ready? I'll do a quick sketch. You'll have to look at your book to get the numbers off of it, though. Ready for number 8? I should have taken a picture of it. Okay. Okay, I have position here. I'm going to call it S. And time in hours. Now, this is the distance from Seattle. And it's kind of a scary, I think all these word problems look scary. This, where it reaches there is 8.5. This is about 1,600. And that's your distance. So Seattle's about 1,600 miles away. I'm trying to think of that. That's probably about right. And then it says, now you're going to leave at 6 a.m. and you're going to return to Seattle 8.5 hours later, and you get there at 2:30 p.m. And the time here is hours, not the time on the clock. So we're going to start at 6 a.m. is going to be t equal to 0. So getting to the reading sometimes is kind of tricky. It says calculate the average velocity of the airliner during the first 1.5 hours in flight. So here's 1, here's 2. I want the average velocity. How am I going to find that? How do you find average velocity? Remember? Yeah, it's the slope of the secant. It's the change in your position divided by the change in your time. Now, this is typical AP question. However, they'll give you a chart. They'll give you a table to read it off. We're going to read it off the graph. If they don't give you a table, you read it off the graph. But you know what? They like to make it easy for the graders, so that's why they do the tables. So if you get both a table and a graph, read your data points out of the table, not the graph. So this is going to be S of 1.5 minus S of 0 over 1.5 minus 0. That's your average speed. Is that calculus? No. That's algebra. What's S of 1.5? Here's you got to read it off your graph now. Looks like, let's just keep it simple, 600 minus 0 over 1.5 minus 0. Now, what would they expect on the exam? By the way, you can leave your answer just like that. You do not have to do anything with it. You don't have to divide it. Don't. I saw a lot of people doing that. simplifying things. You don't need to waste time, and if you do it wrong, we take the point back. You will get the point because you wrote this or this. You have to show your work. If you just come up with an answer, just a number, whatever it is, it's 400. Is 400 miles per hour reasonable? Yeah. I think it's 400, isn't it? I did it in my head. 400. Why can I do things in my head? Because they didn't have a calculator growing up. They didn't even exist. I was a junior in college. That was the first scientific one. They probably had, my dad had, he had an adding machine. And you would have to do this, crank it, because I worked as a secretary. You'd be cranking the machine, adding things up. And he had little paper tapes, and you didn't get the paper tape, and you checked that I put the right numbers in. It's so much nicer today. They didn't have anything. I had my Bomar brain somewhere. I don't think it's in my drawer. I had it someplace. I don't know. Molly, do you have a question? I can't hear you. Oh, I did it. The 600 is right off here. I read it off my graph. Go up 1.5. You have to look at your picture. It's 600. No, S of 1.5 is 600 miles per hour. Just got to read it right off here. Well, you got to look at your graph. My graph is terrible. So you just go up 1.5. You just read it right off the graph. It's this
So
point right there.
It's not S times 1.5.
No, it's S of. Okay. B. Calculate the average velocity of the airliner between 7.5 and 8.5. So 7.5 is here. They just want this one. That's B. So it's S of 8.5. And you know what? If you write that down, you probably get something for that. And most likely, you'll get the right answer. Then you just have to read it up. I'll let you guys do it. Is that going to be positive or negative? And why is it negative? Remember what this graph represents. This is the plane flying to Minneapolis. Why does it stop? That's right. Layover. What else they have to do? They have to put gas in. Because they don't fly planes full of gas. It's expensive. Why? It's S. It's the position at T equals, it gets called F if you want. So they have to stop and refuel the plane. So when I was coming back from Buffalo this summer, we had storms here. So we had to circle for a long time. It was a 2-hour flight, took 5 hours. We had to land in Rochester because we ran out of gas. They don't fly them full. They don't plan. My feeling is, storms in Minneapolis, plan accordingly. But they don't. It's too expensive. And I said, it can't be more expensive to do that than it would be to land that plane in Rochester. But who knows? I'm glad we did. Okay. At what time is the velocity 0? Oh, you're going to look in your graph. It's 0. Looks like it's in here someplace. What do you think that is? This is C, I think. I'm sorry, what? The answer for B is whatever that is. I didn't do the work. I didn't do the arithmetic. I'll let you guys do it. That's the plan. And I think you can read those. Okay, you guys? What time is that 0? What time is this flat here? Noah? When is this flat? Between what? Look at your graph. No, let's make it easier. It looks like it's just 5 to 3. Right? They'd be open to if you included or not. Doesn't matter. Okay, Noah? The other Noah? Okay. That wasn't hard, was it? And it says, give a plausible explanation, refueling, layover. And D, determine the velocity. This is what's going to bother you the most. The velocity at noon. I want an instantaneous velocity at noon. So I want tangent line at noon, which is like right there. And how do you find the slope? Just pick 2 points on your line and calculate the slope. Because they asked for that. It said, Determine the velocity precisely at noon. Because the plane is going some speed. I don't know how fast. Oh my goodness. Okay. One quick little problem because it came up this morning, and you know, you really need to check your answers. And I don't remember where this was, but it was in a problem with multiple questions in it. They said that this was equal to this. What is it? See, we're getting a variety of answers. What is E? It's a number. It's 2.7 cubed. What? Now, so this is just a number. What's the derivative of a number? 0. See why it's important to do some of the little problems? It doesn't matter. It's a number. It's approximately, now I'm going to make my approximately big. It's this, the derivative of 3 cubed. Well, that's the derivative of 27. What's the derivative of a constant? 0. So you see why you don't want to memorize? You've got to understand. Casey? I haven't, well, I did probably show you that. But this is not e to the x. This is e cubed. Do you want me to, I can show you why the derivative of e to the x is e to the x. Well, I don't know how short it is. We're going to use the definition because it's the only way I know how to do it. And you're going to need a graphing calculator. I thought I did this with you guys. Maybe I didn't. Now, exponents. This is the same as this. This is e to the x times e to the h, and we're going to do that in BC Calc next year. You'll do a lot of stuff with exponents. Well, if you have the same bases, what do you do with the exponents? You add them. So to go the other way, if you have them adding, you can make it a product. Now I can factor out e to the x. So it's the limit as h goes to 0 of e to the x times e to the h minus 1 all over h. And I can take this out of the limit operator because this only works on h. I don't care about e to the x. You can have a function in there. You'll have to look at the variable that's in question, and it's the h. So it's e to the x times this limit, and you'll have to go to your graphing calculator to look at that. If you want, how would you put that on your graphing calculator? You would put in y1. I don't want to use h's. E to the x minus 1 divided by x, and I would do a table. And you'll see that this value is equal to 1. Proving it, I can't do it right now. I can't do it yet. I don't think we have the tools to do it. But yes, it can be proved. And that's what you do in upper level math. You take the calculus and you prove all these things. We're not going to do that, thankfully. We're not going to do proofs. And I can prove some things, but not everything. It's been a long time since I've proved all these things. But I probably could prove that one. I have to think, oh. I don't think, maybe a conjugate would work, but I don't think so. I have to think about how to do that. So yeah, you guys say, well, you can come in here and do this stuff. I should. I've been doing this for 20 years. And if I couldn't, then you got a problem with me. Tomorrow morning, I will be here. You need to just come and work on homework. I will reassess on Monday if you need. I'll be there Monday morning if you need to come in after school and just work on homework.